Good day to you, my dear friends. It's time to solve some LeetCode problems. The conditions are not perfect and I do not have much time, but if I want to solve a LeetCode problem every day, then I must do it every day. So here I am, and now let's start with a problem from yesterday. Yeah, this ugly beast. I think yesterday I ended up with this code. Yeah, like this. And let's even try to run it. And it's even green, but there are more test cases. Let's submit. Yeah, and here they say to us that we can remove all subsequences from here in just 2 steps. And I couldn't understand how this is possible. And I went to a discussion section to see maybe this is a bug, but it wasn't a bug at all. What they meant here when they say that we need to remove palindromic subsequences from S, they do not mean that letters should go literally one after another. So in this situation we can just take all A letters and it would be our subsequence number 1, palindromic subsequence, and then all the B letters, and this would be our second palindromic subsequence. So every string that is not already palindromic can be removed in 2 steps, and the palindromic string can be removed in 1 step, of course. So no, it's a trick. It's a dirty trick, because subsequence, it's sequence. They should be sequential. No, I feel tricked. They played me. So what is the solution? Well, we check if this is a palindrome, and if it is, we return 1 because we need just 1 step, and if it's not, we return 2. And I believe this is it. Let's submit. Yeah. And I told you yesterday that there must be some trick to this, because otherwise it's just too hard to be an easy problem with so many solutions, accepted solutions. By the way, let's go into solutions section for our favorite Ruby language. There are not that many solutions, but each and every one of them is somewhat funny, because here we check if our string is empty. Let's go back to our description of the problem. Well, our string can't be empty, so we shouldn't check for that. Let's see the next one. Well, it's a funny one. They do it in 1 line and they create a palindrome method for string class. Well, it's a funny one, but of course it's not a one-liner. Probably it's a better approach, but to solve this small problem, this is probably an overkill. Next one. Of course, we check if this is empty. Next one. They want to check if this is empty too, you see, but he wants to do this in one line. That's why it looks like this, but still we do not have to check for this. And the last one, the same story. So I think I should upload my solution, it's the most optimal one. Now for something completely different. Oh no, let's go to my profile. Uh-oh. This problem. Final prices with a special discount in a shop. I explained this problem yesterday too. But in the end I said that maybe it would be nice to solve it with the map method. Well, no. Actually, it's not the best way to do this, because map method returns a new array instead of the one we already have. So the best solution is my previous solution. And I uploaded it, by the way, so upvote my solution. Here is it. It's the one with the longest title. Yes, each with index is the best approach here, and modify an original array along the way. I believe so. Who knows if this is true? Now, here is a problem that I solved a few days ago without any witnesses, so now I want to tell you all about it. Let's reset it. So, create a class array wrapper that accepts an array of integers in its constructor. So we can do this immediately. Now this way, old school way of working with the classes, well, not old school, because modern way with using like class new, it's just a synthetic sugar over this old approach. So this is how we solve the first part. Then when two instances of this class are added together with the plus operator, like this, the resulting value is the sum of all the elements in both arrays. And this is just a hard way of saying that when we call, say, object 1, we want to sum all of its elements, like 1 and 2. And when we call for object 2, we again want to sum all these elements and get 7. And we already have a method for this, not a method, like I don't know how to call it, a place where we should put our method. And of course, how do we sum things? Yesterday and a day before that I showed you reduce method. So let's use it. And remember, as I told you yesterday, first there is a accumulate such a of a word, then it's a value, and we add them together, and also we use 0 as a starting value, probably like this. And the third thing we want to do is to turn our array into a string, like this. And originally I did something like this. String, I believe it's called. Let's check this. Why do we need to string? Well, because otherwise it will return just 1 or 2, a string like this. So we want to add our brackets manually. And of course you can do this using this approach. Oh no. Oh, of course. Hey, and it works. But there is even a better approach that I find in solutions section. Maybe it's here. Yeah. In a JSON API there is a stringify method. So this is it, and I believe this is the best approach. Another good approach, maybe not a good approach, but a good practice would be to do something like this. Let's call it value. And here we just return this value. And also we can do something like this. And here we of course return this string. Now let's test if this works at all. Great. Well, another good solution. Now well, let's solve something new. You know, not a day without a new LeetCode problem solved. An easy one, of course. And I think page number 4 already. Counting bits. So given an integer n, return an array n's of length n plus 1 such that for each I, and I is the number of ones in the binary representation of I. Yes. How do we get a binary representation? Let's say we have some integer and we just convert it to string with argument 2, and we will get a binary representation of this integer. And we should do the same for every character. So when we get n and it is like 2, we want to do n plus 1 times do, say I, and of course you want to have an array ans as they ask. I to s two, and we will have a binary representation, and then we want to use chars. Let's use chars, and we will get an array of all the characters in this string, and we should just count ones, but not ones as an integer, but one as a string, because we are using chars here, not digits. Okay. And let's return ons. You see how easy it is when no one tries to trick us, these dirty bastards. First try. Yoo-hoo! And so this is it, I believe. Unfortunately, I do not have time for anything else, but it was a nice little stream. So thank you very much for being here, and I'll see you tomorrow and many days after that. Goodbye.